Welcome again to Learning Outcome 3. So we're done with the first. The second and third. My name remains Temitope Babalola. So I will be going through Learning Outcome 3. So in Learning Outcome 3, we have to understand exponentials, logarithm, trigonometry relating to what? To engineering problems too. That things we have to actually what we do. So the learning outcome is divided into three parts. The first part is to demonstrate problem solving using exponential and logarithm. Demonstrate problem solving with arcs, circles, and sector. Demonstrate problem solving, including what? Right angle triangle. So today, we'll look at demonstrate problem solving using exponential and logarithm. That is why you see us using what? Exponential directly here. So let's start with the exponential function. So when you see exponential functions so far, and this course we have what? We have looked at many functions too. So in an exponential function, we have variable. The variables is in what? Is in index form. So examples of exponential function include what? Can you see? 2 to the power of x, 5 to the power of x. Can you see? To the power of what? To the power of a variable. So can I just ask you, can you give me, based on the examples you have on the screen with you here, can you give me example of an exponential function? Can you give me one? So it's going to be like y to the power of 2, y equals to 2 to the power of x, and so on. Just make sure that is to the power of something. So look at this one now. So that where a is greater than 0 and a is not equal to what? It's not equal to 1. So you have probably heard about exponential increase and decrease, or exponential growth and decay. So when you say things grow exponentially, it means that what? You just see a rapid growth or decrease in what? In that in the graph. So a quantity that's changed exponentially either increases, decreases rapidly at the time. So for instance, look at this one now. You can see that the increase was slightly until it got to this place. It just started increasing. These are actually what? Exponential functions. So don't forget that it's not a must be greater than 0 and a is not equal to 1, because if you see it equal to 1, there's no way you can actually form those exponential functions there. So these are actually what? Exponential functions. So let me try and actually give you a question to do. So I'm going to give an example before I go to log. So I want to give an example. If you have something like this, if you have a curve, you have a curve like this. You have a curve like this. Then this one, the coordinates here with a different pen. This is y. This is x. The coordinates here is 0, 3. And the coordinates around here is 2, 12. Can you see? You have those two coordinates there. So say at the sketch, the equation for the sketch for the curve is this: a b to the power of x. Can you see that it's exponential to the power of x? And say that b is more than 0. And I ask you to find what a and b is. So you know what you will do. they have given you what? 2 coordinates. Last week we were doing graphs, and I told you the first coordinate is x, the second coordinate is what? Is y. So they have given you this x and y. This is what? X and y. So x will be equal to, for this one, equals to 2, and x equals to x equals to 2 for that one, and then y equals to 12. For the second coordinate, x equals to 0, y equals to 3. So you now substitute those things, y equals to, since you know that they have given you the equation, and you know that for the first one, x equals to 0, y equals to 3. If x equals to 0 and y equals to 3, if x equals to 0 and y equals to 3, so just put that one down like this. So that means that you put that one to be x equals to, so you just put it, substitute it. So anywhere you see y, you will put 3 there. Anywhere you see x, you put 0 there, equals to a b to the power of 0. And you see, so you know that in indices, anything that is raised to the power of 0 is 1. So it's not going to give you what? 3 equals to a times 1. A equals to 3. Can you see? That's the answer. You know what? That is a. So if that one is a, what is now b? Y equals to a is what? 3. B, you don't know. And put x there. You can use the second coordinate. In the second coordinate, can you see that x is 2 and y is 12? So you first put 12 here, equals to 3 times b squared. You divide both sides by 3. So that gives you what? 12 equals to b, so 4 equals to b squared. B, we got to what? Square root of 4. B equals to 2. That's it. So that means that a is 3, b is 2. I'm going to mute myself, then you can use that against what I actually did for you. So you can see those type of functions there in this day, in those type of functions there. So we're going to do exam style questions too, so that at least we can actually make sense of what exactly we're actually talking about here. So let's look at some questions. So you can also draw those graphs too, So for example, now if you have, if they give you like an exponential function graph, it can also be drawn, in a different. So for example, now they give you, it's a complete the table of y for y equals to 3 to the power of x. So x, y, minus 2, minus 2, minus 1, 0, 1, 2. So y equals to 3 to the power of x. So it's going to be what? Y equals to 3 to the power of minus 2. Y equals to 1 over 9. So you put 1 over 9 there. So when x is minus 1, so anyway you see x, you put minus 1. Y equals to 3 minus 1. Y equals to 1 over 3. Anyway you see x, you put 0 there. Y equals to 3 to the power of 0, also 1. Y equals to 3 to the power of 1, equals 3. You put 3 there. Then y equals to 3 squared equals to 9. That's it. Then you now plot the graph, just like I taught you the last time. how to put those values in there and actually what plot the graph. So that's actually what you can do plotting graphs with actually what with exponential functions. So let's see maybe we can actually do some other things there. So now let's look at logarithm quickly. So instead of find p if pq equals to this. So you keep it on that. So logarithm functions are actually what similar to exponentials too. So for logarithm, so to avoid using trial and improvement, we need to actually define the power for y. So and number x2. So y is defined as what? As this. So and so if you have this one, a y equals to x. So if you want to take the logarithm of it, it's going to be what y equals to log with x. That is the how to find actually what the logarithm of that. So that means that if you have what's it called a, if you have 2 to the power of y equals to 64, so that means that y will be equal to log base 2 64. So y is going to be equal to 8. No, I mean this 6, yeah. Yeah, 4. So the same thing applicable actually what's here. You can actually see those settings directly there. So just like this one now. So 2 to the power of 5. Sorry, that was going to be 2 to the power of 6 equals to 64. Sorry. So 2 to the power of so it's going to be what? Let me just put that one there. So the previous one, so you won't forget. Apologies for the mistake. It's going to be what? Log base 2 64 equals to 6. So now this one too, you can see that log base 2 32 equals to 5. That is it. You can try that one on the calculator. You realize that actually that one is actually what confirmed. So yeah. So let's look at lots of things now. You know, I told you that anything raised to the power of 0 is what? Is 1. Anything raised to the power of 0 is actually what is 1. So you have this one. You see, a to the power of 0 is what? Is 1. A to the power of 1 is a. So if you do this log for this one too, log a to the power of log a1 is going to be 0. Log a is going to be equal to 1. So if this is this and now is this, so we said x equals to am, y equals to what? An. Then xy will be equal to like this. So you can actually put those ones down too. Don't forget how to do. I just want to like us to do questions on it. So this one is the power law. Same thing too. So then you have something like this: x to the power of n equal to this. Then xn equals to a. So n equals to what? X log n. So don't forget that at the start here, you see that clearly that m equals to what? Log a, log base a, x. So you change it back to give you what? X equals to a this. So an x and so you put multiply power of n to both sides. So equals to a n. Then if you know that this one is what amn, that means you that m n equals to log base a x to the power of n. Then n log a x equals to log a x to the power of n. So you put that one. So I said express this in a single logarithm. So when you say express it in what? In a single word logarithm. So you must be able to actually what? Look for a way to collect the like times, in those type of questions too. So please, at the end of the class, I will want us to do questions together. So please try and open up at that time. So 2 log a 3 log a this thing. So you see this one. So plus this minus 2 log 6 equals to, you change this one. This is the power. So it comes here, becomes 3 squared. That's what it turned into. This one too, it stays the same. This one becomes 6 squared. So 3 squared is 9. That's why you see it changes there. It's 36. So all of them have the same base. You can just when when you actually multiplying logs, when you are adding logs together, is multiplication. When you actually divided, that is actually take away. So you can see that this one is this multiplied by this divided by this one. So I give you that. So we're going to actually do some questions on that. Loss of logarithm. You already actually now I want us to do. So let's do some questions. So I want us to do some questions here. I have to just clear it, just it's me for 2 minutes. Okay, look at questions like this. Let's look at this one. Let's solve this equals to that one. Is that solve the equation when we have what? We have to write what in front of the types of actually 2 here. So you see that both of them are actually base 5. So it's a lot easier for you to actually to solve. So it says equal to this. And don't forget that this one is also log 10. So to evaluate that, 5 equals to what? Equals to 1. Because you can see clearly that what's it called? Let me just slightly step back slightly for you so that you can know exactly what, because what they did was that they can rewrite these two to this because it's the same thing. log 2 is same thing as what log 5 is, because 5 squared is 25. So that's what we're doing here. 2 equals to what? 2 log this. So that's that one. So log 5 is 1. So you can turn it to what? Log 525. Just like for 3 now, you can talk log 3 to like log 5 125. So we've turned that one. So all of them now have the same base. So because this one is actually what multiplication, so can you see it's going to be what? Log 25x. This one stays. So you cancel the logs out. 25x equals to 10, x equals to 0.4. Just digest that one. Then I want us to do one that does not have any answers. 2 logs 4 minus x equals to log x minus x plus 8. So that's x squared minus 9x plus 8 equals to 0. See? So what you have to do, basically is that you have to look for a way, because these two, you can see that this 2 is here. So you can transfer the 2 to the power like this. So it becomes what? 4 minus x. It's part of the law of indices we actually want to cover initially. Cover lots of logarithms, sorry. So it's going to be what? Log this equals to log 8x plus 8. Can you see? They're done with the first point. So because both of them are actually what? The same log, so you can just equate them together. 4 minus x all squared equals to x plus 8. Then that gives you 16 minus 8x plus x squared equals to 8 plus x. Then you now take away x from both sides. Take away x from both sides. And you also take away 8 from both sides. So that gives you x squared minus 9x plus 8 equals to 0, as required. Can you see? That's it. Can you see? I've changed it to that, so you can actually digest that one. You see what I actually did? It's very straightforward. You don't need to bother yourself. Just follow exactly what they actually put there. So you can actually have a go on that, solve it. Say you solve that equation, you can actually have a go. Then I'll come back to actually do it in like 2 minutes. Do it now. So if you have to solve this question, you have to find the value of y. So you just need to actually apply the law of indices. Both of them have the same base. So what you need to do here is that you just look at it that this is take away. So it's going to turn to like divide. So it's going to be log 3, 12y plus 5 divided by 1 minus 3y equals to 2. Then that gives you what? 12y plus 5 over 1 minus 3y equals to 3 squared. Equals to 3 squared. Then 12y plus 5 equals to 9, 1 minus 3y. Then 12y plus 5 equals to 9 minus 27y. Then I'll give you what? 39y equals to 4. You see, y we got what? 4 over 39. So that is it. You can see that one actually what clearly actually what's shown. I don't know, maybe you have actually what attempted those questions before, but if you have not done that before, I do it again. If you have not done that, you can also look at these two. You can want to actually what to see if you can gain one of those things there, and actually what know exactly how actually what approach it. But what I can tell you is this: the most important part of this work is for you to know the laws of logarithm. That is very, very important. So this is the final question I'm going to do before I actually want to wrap it up, so that the video will not be too long. So log 2 x equal minus log 2 equals to 3, as shown. So now you can see this one. It has to actually what solve it to find the value of x. So you have to do this one. This one gives you what? So the power first, the 2, you move it here. So that gives you what? X squared. It could be what? Log 2 x squared minus log 2 is equals to 3. So you put that one out like that. So this one is squared. You put that one to be this thing. So now, so since it's it's like that, that you want to make everything log base 2. So it's going to be what? Log 2 x2 minus log 2 root x equals to 3 log 2 2, because that one is going to turn to 1. So since all of them now have log 2, so you now put it this way, that log 2 x squared, because it's minus, it's going to be x squared over root x equals to log 2 cube. Then x squared over root x equals to 8. Then x 3 over 2 equals to 8. X equals to 8, 2 over 3. X equals to 4. That's it. So the examples are actually what's there. So if you don't know exactly how I did this step, so you can see that one I did that one. So this one, don't forget that when you say something like this, is x to the power of half. So it's like we are doing what? X squared divided by x to the power of half. What is 2 minus half? That's going to be 3 over 2. So that's how you go 3 over 2 like this, because it's going to be what? X 2 minus half. That gives you what? 3 over 2. So 3 over 2 equals to this. So if you want to find out, just multiply both sides by 2 over 3. This one become 1. That's why you see 1 there. This one will go 2 over 3. So this one is now going to be x will be equal to what? The cube root of 8. Then you square it. That gives you 4. Right. So just try and study those things I actually was saying to you. Then you pick one or two things there together. So all right. Thank you for joining. Thank you. Bye.